Let's have a go at the 2026 Add Math paper. Number 1A part 1 wants us to determine the value of the following expression given the answer in its simplest form. We have two fractions, therefore we need a LCM. Let's first reduce the root of 27 to see what that could potentially be. The square root of 27 could be rewritten as the root of 9 multiplied by 3. So that's the root of 9 multiplied by the root of 3. This is going to be 3 root 3. And so this would be our LCM. So we have 3 root 3. Then we have root 3 goes into root 3 once. So 3 by 8 is going to be 24. Minusing from that 27. Well, that is 3 root 3. So we're going to have 5 on the numerator. This would give us... This would then give us 24 minus 5. That's 19. That's going to be 19 over 3 root 3. However, in surds, we aren't supposed to leave a surd on the denominator. We therefore need to rationalize this by multiplying by root 3 over root 3. Right, so let's go ahead and get rid of that surd. We would then have 19 root 3 divided by root 3 by root 3. That's going to be 3, so we're going to get a 9 on the denominator. Right, so we have 19 by root 3 over 9. Part B wants us to factorize the following polynomial completely, giving your answer as a product of its linear factors. Okay, so we need to go ahead and break apart this polynomial. Here it seems as if we can make a substitution. So let's make that substitution first and see how that helps. So let's let y equal to x squared. Then we would have y squared, because this is x squared squared minus 29x squared. So that's going to be y squared minus 29y plus 100. Okay, so we could then factorize this quadratic right here. And this is factorized into, so what are the factors of plus 100 that when added together would give us minus 29? 100, we have 1 and 100, we would have 2 and 50, we would have 4 and 25. Our minus 4 minus 25, that does give us plus 100, and when added together, that does give us minus 29. So we then have y squared minus 4y minus 25y plus 100. Right, so we would then have y into y minus 4. Then we have minus 25 into y minus 4. We then get y minus 25 into y minus 4. Right, so at this point here now, we could go ahead and finish up this factorization by resubstituting the values for y. So we let y equal to x squared, therefore we're gonna have x squared minus 25 into x squared minus 4. And what we have here is two difference of two squares. So the first we could rewrite as x squared minus 5 squared. Then we have x squared minus 2 squared. Right, and we know a difference of two squares tells us that if we have a squared minus b squared, its factors are going to be a plus b into a minus b. Same thing again, so we would have a plus b into a minus b. Right, and these would then be the four factors of the polynomial. So let's just state that x4 minus 29x squared plus 100 is equivalent to, we'll write it here, x plus 5 into x minus 5 into x plus 2 into x minus 2. Right, so moving right along. Part C says, Figure 1 shows the steps in a student's solution for the equation log to base 3 of 5x plus 1 minus log to base 3 of x minus 4 is equal to 2. The student made an error in the working which resulted in an incorrect solution. Right? Figure 1 shows the work solution, and they would like us to identify the step in which the student made the initial error and correctly rework the solution from that step. So let's look and see what we got here. Right, so step 1, we apply the division law of logs, or the minus law of logs as it is sometimes called, where it tells us if we have two logs being minus apart having the same base, we can rewrite that as a quotient of the two numbers. So we have 5x plus 1 divided by x minus 4 is equal to 2. Okay, good so far, good so far. Then from that step, they took the anti-log. So the log answers the question, what power do we have to raise the base 2 to get the number? Right, so there's where the mistake took place. The log answers the question, so if we have 2 cubed is equal to 3, this in log form would say that log to base 2 of 8 is equal to 3. The log answers the question, what power do we have to raise the base 2 to get the number? So step 2 should have read, we have to raise 3 to the power 2 to get the number. Because again, the log answers the question, what power do we have to raise the base 2 to get the number? Right, so here we have to raise the base of 3 to the power 2 to get this number. Right, so let's indicate that the error took place in step 2. And then they want us to correctly rework the solution from that step. Okay, so what's going to happen here is instead of having 2 cubed, which is 8, we multiply this x minus 4 by 8, we're going to have x minus 4 multiplied by 3 squared, which is 9. So from step 3, I'll rewrite step 2. So that'll be 5x plus 1 divided by x minus 4. This is equal to 9. And so then we need to multiply both sides by x minus 4. So we would have 9x minus 4 9s at 36. This is equal to 5x plus 1. Getting all the x's on one side, we see that 9x minus 5x is equal to, that's 36 plus 1. Therefore, 4x would be 37. Therefore, x would be 37. X would be 37 divided by 4. We can leave it like this, or using the calculator, we get 9.25. Right? It seems as if this was so close to being a nice round number, but that wasn't the case. Let me just double check that. So that's 3 to the power 2, that's 9. Yeah, so 9 4 is minus 36, 5x plus 1. Yeah, so we would get this here. Right, so moving right along. Part 1 wants us to determine the values of m for which that equation has equal roots. Well, we know for an equation to have equal roots, the determinant must be equal to 0. right? And the determinant is given by b squared minus 4ac. So let's identify that. So b would be m minus 1, a would be 1, and c would be 2m plus 3. Therefore, b squared minus 4ac must be equal to 0. Right? So m minus 1 squared minus 4 lots of a is going to be 1, c is going to be 2m plus 3. So let's go ahead and expand. We're going to get m squared minus 2m minus 2m, sorry about the pinging, minus 2m plus 1, right? And then we're gonna have minus 8m minus 12, right? So let's go ahead and simplify. We have m squared minus 10m minus 11. So now we need to factorize. We need two factors of minus 11 that when added together would give us minus 10. So that would definitely be 1 and 11. It would be minus 11 and plus 1. Multiply them, we get minus 11. Add them, we get plus 10. So we have m squared plus m minus 11m minus 11. We then have m into m plus 1, then minus 11 into m plus 1. We then have m plus 1 into m minus 11. Okay, so we then set this. All of this should be equal to 0. My 0 was on the wrong side of the equation. Right, so we see then that either m plus 1 is equal to 0 or m minus 11 is equal to 0. Therefore, m is equal to minus 1 or m is equal to 11. And these would be the two values of m, which gives the equation equal roots. Part 2 wants to hence determine the value of x that satisfies the equation. Right, so let's see which of these values of x would indeed make the equation satisfied. Right, so let's sub in these values of m. Let's sub in these values of m and see what the corresponding values of x would be. So first let's do m is equal to minus 1. So when m is minus 1, we're gonna have x squared, and that'll be minus 1, so that would be minus 2x. Then when m is minus 1, that's 2 by minus 1, that's minus 2. Minus 2 plus 3, that's plus 1, and that's equal to 0. So we then need to factorize this. This is going to be, this right here is going to be x and x. Then we have minus 1, right? Because we have x by minus 1 is minus x, then minus 1 by x, that's minus 2x. Right? So this is fair. We have x minus 1 all squared. Right? So we see that x is therefore equal to 1. All of this is 0, x is therefore equal to 1. Now we see when m is equal to 11, let's see what we get. That's going to be x squared. Then we have 11 minus 1, that's plus 10x. Then we have 2 by 11, that's 22 plus 3, that's going to be plus 25. right? So now we need to factorize again. Let's see. So we're gonna have x, we need two factors of 25. So that'll be 5 and 5, plus and plus. Right, 5 by x, that's 5x, 5 by x, that's 5x, we get 10x, 5 by 5, that's 25. And so we have another perfect square, so we see that x would therefore be minus 5. And there we go. Right, so moving right along. 2a part 1 wants us to substitute that into the exponential equation that. And let's see what we get. Firstly, I would rewrite this first term to be in the form 2 to the power x. So we're gonna have 3 into, that's 2 to the power x squared minus 2 to the power x minus 4 is equal to 0. We make our substitution, we let y equal to 2 to the power x. We then have 3y squared minus y minus 4 is equal to 0. Right, factorizing here, we're gonna have 3y, we're gonna have y. Right, then we need two factors of minus 4 to give us 1 there. So if I have 3, I need to have minus 1 here, I need to have plus 4 here. So let's see, 3y by y, that's 3y squared. 3y by minus 1, I did this wrong, so this needs to be minus 4, this needs to be plus 1, right? So 3y by y, that's 3y squared. 3y by 1, that's plus 3y. Minus 4 by y, that's minus 4y. So we do get the minus y in the middle. Then minus 4 by plus 1 is minus 4. Right, so here we see, okay, so I guess they did not ask us to do all of that. They just asked us to make the substitution. And so I went ahead with part 2 one time, which is solve the resulting equation in terms of y. Right, so finishing this up, we see then that either 3y minus 4 is equal to 0, or y plus 1 is equal to 0. Therefore, y is equal to 4 over 3, or y is equal to minus 1. Okay, and they did not seem to want us to finish up and solve for x. Right, so part B wants us to find the range of values of x for which this is the case. Right, so let's get about to doing this. Now there should be an indicated condition here. They should have indicated that x cannot be equal to, and what would that value be? Give me a good guess. It's gonna be minus 1. Because if x is minus 1, we're gonna get 0 on the denominator. So x cannot be equal to minus 1. Okay, we don't need to go through. Right, and we have to ensure that x is not equal to minus 1. So let's get to this question. We have x plus 5 divided by x plus 1, and that's less than or equal to 0. We go ahead and multiply throughout by the denominator squared. So we're gonna have, well, if we multiply anything by 0, it's gonna remain as 0. If we multiply, let me write it again. So that'll be x plus 1 squared. And we also multiply by x plus 1 squared. Right? And so on the left hand side, these would cancel. We would have x plus 1 into x plus 5. That's going to be less than or equal to 0. Right, so we go ahead and solve this to find the critical points. We set this equal to 0, so we say x plus 1 into x minus 5. We go ahead and set this equal to 0, and we see the critical points. the critical points would be x equal to -1 and x equal to 5. Right, so to find the actual solution, we go ahead and put a sketch. We give them a sketch. Let me use some deeper colors for the axes. Right, and this is the graph of this graph would be x squared. We know the roots are going to be at -1. Let's draw in the roots. So we'd have roots at -1. We would have a root at 5. Right? What's going to be the minimum point of this graph? So actually, let's do that quickly so we have a bit of an accurate sketch. So our graph would be x squared minus 4x minus 5. If y is this, then dy dx is going to be 2x minus 4. And where's dy? If we set dy dx equal to 0, we're going to find our turning point. We see that 2x is going to be 4, so x would be at 2. So the turning point, the x value of the turning point is x equal to 2. So that would be somewhere here. So, and what's the y value that goes along with that? So when x is 2, if you let x equal to 2, y would be it as 2 by 1 is 3. I'm using this equation here. Then 2 minus 5, that's minus 3. The y value would be at -9. Oh, that's a deep one. And so let's pull this down a bit. We would have 2, and we'll call right around here minus 9. Right, so our graph looks something, this wouldn't be perfect, but something like this. Right, and we want to see exactly what the range of values are going to be. Well, we're going to have a solution. Let me use black. We're going to have a circle at -1, but we cannot include -1 in the answer. Why? Because if we look at this graph here, x cannot be -1, so we put an open circle. Right, and this wants to know where is this graph here? Where is this quadratic? Less than or equal to 0. Well, if I'm looking at the quadratic, I know I have 0 here. This would be 1. This would be 2, 4, 6, 8. Here would be -2, -4 going down the road. Right, so I'm saying, okay, as the x values get less than -1, okay, I'm starting to get greater than 0. But as the x values get bigger in terms of less negative, as the x values get bigger or closer to 0, my y values should all be below 0. And as x gets less than 5, because when x gets greater than 5, watch, the graph is going up. These x values here would all indicate that the graph is going up. But as x is less than 5, the graph is going to be less than 0. So the region we are interested in would be this region here. Right, so x has to be greater than -1, and it has to be greater than or equal, less than or equal to 5. So the solution set is x such that x is going to be greater than -1. Put that wrong side. So -1, x is going to be greater than -1, but it's going to be less than or equal to 5. Right? And that there would be our solution. Part C tells us that an accountant is offered a 5-year contract with an annual increase. The accountant earned a salary of $56,000 and $61,000 in the 3rd year and 5th year respectively. if the increase was the same each year, they want us to calculate the total amount earned at the end of the 5-year period. So what are they telling us here? They're telling us here that the amount in the third year, so we'll call that T3, is going to be 56,000, and the amount in the fifth year, that's going to be T5, is going to be 61,000. Right? And they said that the increase was the same each year. So that sounds to me like an arithmetic progression. And what's the formula for the general term in our AP? That's going to be A plus N minus 1 by D. Right? So using this general form and these two equations, we would have two equations to solve for our unknowns. And let's go ahead and do that. So we see that T3, which is 56,000. So let's fill that in. 56,000 is T3. Therefore, that means 56,000 is equal to A, whatever A is, plus N minus 1. So that's 3 minus 1. That's 2D. Then 61,000 is equal to A plus, and that's going to be 5 minus 1, that's going to be 4 by D. Right? So we could neaten this up. We could rewrite this as 2D. And now we have two simultaneous equations, which we could solve, which we could definitely solve. Right? So they're already in this order, so I'll just minus them as are. I know I'll get a negative value. So let's do equation 1 minus equation 2. Let's see what we would get. 56,000 minus 61,000. That's going to be minus 5,000. And that's going to be equal to, and the reason I just minus them as is because we have a A here and a A here. They are going to cancel. So A minus A, that's going to be 0. 2D rather, minus 4D, that's minus 2D. Therefore, D, the common difference would be $2,500. Right? So we could go ahead and use this now to find what A is. So using equation 1, we see that 56,000 is equal to whatever A is plus 2 lots of D, which is 2,500. Right, so 56,000 is equal to A plus 5,000. Therefore, A would be equal to 56,000 minus 5,000. That's going to be $51,000. Right, so we know what A is, we know what D is, and they want us to calculate the total amount earned at the end of the 5-year period. So they want the summation for the 5 years. They want the sum of the first 5 years. So that is given by S sub n, and S sub n for a geometric progression. What's that going to be? That's going to be n over 2 into 2a plus n minus 1 by d. Right, so let's go ahead and find that. So S sub 5 would be n over 2. So that's the end of the 5-year period. So that's going to be 5 over 2 into 2 by 51,000 plus n minus 1. That's 5 minus 1. That's 4. D is going to be 2,500. Right, so we're going to have 2 over 5 into, that's going to be 102,000, 51,000 by 2, plus that's 10,000. Right, so I'm going to use the calculator and let's see what this gives. And I got $280,000. Part 2 wants us to find the sum to infinity of the following geometric series. Well, what's the sum to infinity? This should have been given in the formula sheet. So the sum to infinity of a GP is 1 over, sorry, is going to be, rather, is going to be a over 1 minus r. Or we see what the first term a is going to be. The only thing we need to determine this is what r is going to be. Right, so let's see what r is going to be. We get r by dividing two consecutive terms. So let's take minus 18 over 5. We're going to divide that by 6. So that's the same thing as saying 18 over 5 multiplied by 1 over 6. This is going to be minus 3 over 5. Right, we could double check this by trying two other consecutive numbers. So 54 over 25 divided by 18 over 5 is the same thing as multiplying by 5 over 18. This is negative. So this will give us 1. We get 5 here. We get 1 here. We get 3 here. Yes, the common difference, common ratio rather, is indeed minus 3/5. Right, so we know what a is, we know what r is. Let's go ahead and find this sum. That's going to be 6 over 1 minus minus 3/5. Right, so that's going to be 6 over 1 plus 3/5. So that is 5 over 5 plus 3 over 5. That's going to give us 8 over 5. So we then have 6 divided by 8 over 5, or 6 multiplied by 5 over 8. This is going to give us 30 over 8, or this could be reduced to 3 and 2/3. Let's see, 24, 6 over 8. No, not 2/3, rather 3/4. 6 over 8 reduces to 3/4. Right, so that would be the sum to infinity of this